Cool. Alright, so x minus 1 bracketed, x plus 2 bracketed, x minus 3 bracketed. Conveniently, this is all already factorised for us. I'm going to say that we want this thing to equal 0. Okay, I want to now solve this equation. Okay, any thoughts? Yep.
We'll pick one of the bracketed values and then divide off the other two, and then I'll subtract or add the
Okay.
number.
Yes, you've massively overcomplicated it, but yeah, that would work.
So for example,
one in the function and like keep going until I find one that equals 0.
Okay, so you could just throw numbers at it. Okay, that might take a lot of time if the solutions don't happen to be nice numbers particularly. Yeah, TJ? No, you just had to turn it off. Okay. If I did this, what does that look like? What kind of equation? Quadratic, right? How do you solve that quadratic?
One of the x's would either be -2 or +3.
Right, x would equal either -2 or +3. Yeah? Okay. If I have this, well actually, sorry, go back to that for a second. Why does that work?
Because then one of them equals 0 and it's just the other one times 0.
Perfect. You're using null factor law, right? You're saying, okay, if x is -2, then this bracket will equal 0, so I don't care what the other thing is, because 0 times anything is 0. Well, I've just got an extra bracket. Would that affect this being -2, this being +3? No, because you still get zeros out. So, therefore, x equals either -2, +3, or 1. Done. That's why factorising is so handy, and that's why you do so much of it. Right? Because once something's factorised, you get free solutions, which is great. Okay. What about this guy? Make it equal 0.
X plus 2 and x minus 1.
X plus 2 and x minus 1. X minus 4, hopefully. Cool, that easy. Now there's a slight difference between this guy and this guy, which is there's a square going on. Okay. What does that do? For now, nothing. Right? Because I can only put in 2 into this to make it go to 0. I can only put -4 into this. It looks as though this thing only has 2 solutions. If I told you to, no, I won't spoil that. Yep. We'll get to it later. Cool. Okay. More often though, you're not going to have it pre-factorised for you. You're going to get some ugly thing that's expanded. Cool. All right. I want to solve this thing equals to 0. What would I do? Okay, I could throw numbers at it in an attempt to...
Maybe substitute something for x to make it all equal 0.
Okay, I need something in there to equal 0. What am I going to do after that?
Factor x minus x, and I need to make a factor of x.
Okay, and then I'm going to use that factor too.
Long division.
Right, there we go. So ultimately we need to factorise this thing. Given that we've just done a whole lot of polynomial long division, we'll use that to factorise it through. Cool. Any suggestions on what you should or should not pick? Yep. 3? Okay, why 3?
Oh, no. 4. No, 6.
Okay. Any reasons as to why?
Pardon?
Why? Why 3, 4, 5, 6, whichever number you ended up not picking?
I choose 3.
You choose 3, okay. Why 3?
Because 3 times 2 is 9, 9 times 3 is 7.
Okay, how does...
Oh, no, that's not...
How is that relevant to this?
Oh, no, because...
I don't know, it might be, but I don't know exactly
we're
what
trying to
you
make it equal 0. And
yeah.
If you put like 1 and... Oh, it could be negative.
Oh, you got negatives as well, okay.
I got -3.
Cool, Riley?
you should probably pick a negative because there's like such high values getting subtracted. Oh, well, so
Okay.
I say -2. -2 is the answer.
-2, you reckon? Okay.
it is the answer. No.
No, that's the answer.
Yep.
You probably want to pick factors of C.
When you say C,
40, -40.
40, right? Because in this case it's like D. Yeah, you've got
Oh,
A, B,
yeah.
C, D.
Yeah.
Cool, so of the constant at the end?
Yes.
You want to pick factors of the constant. Good. Why?
because then the other things are more likely to cancel out or be with the constant. Not
Not sure what your wording's a bit odd, so I'm not sure what you mean. But I'm going to put it in my words and see if you say, yeah, I meant that. If I expand this out, what would I get as my constant? It's just going to be this times this times this.
Yeah.
Yeah, because I end up with a pure number, so none of the x's are in play. Okay, well, -1 times 2 times -3 is 6, right? What are the factors of 6?
3, 1, 6, 2, 3.
Right, 1, 2, 3, and 6, right? Well, and positive negatives can be in there as well. Great, well, that gives me a short list of what I should try. Okay, what are the factors of 40?
2,
1, 2, 4,
-2,
yeah, we'll include negatives as well. So 1, 2, 4, 5,
10,
yeah, you missed one.
6,
8, 10, 20, 40, right? So we've got 8 things to choose from and they could be negatives.
16.
What do you want to start with?
2.
Okay, so 1 is the first thing you should probably start with. Is that going to work?
No.
No, you can rule it out straight away. Cool. Is 2 going to work?
-2, yes.
Okay, so that's what we're going to do, right? You start from the lowest thing,
Yeah.
work your way up. Usually it's a good idea to flip-flop between negatives, just so you don't go all the way up to 40 and realise, oh, it's none of the positive numbers. Now I'll go to -2. Oh, it's -2. Usually you want to flip-flop through. Cool, cool. On you.
Damn it, it's not -2.
Might be, might not be. I do know, but I'm not going to tell you. You have to verify for yourself. You're just trying to find one factor. Doesn't matter. Doesn't matter which factor you find. You're just trying to find one of them.
And do we solve it when we go?
Do we solve one to it? Yeah, if you're happy to, go nuts.
When we have to solve it, does that mean we have to put it in that form of the first equation?
Ideally, yeah.
Cool, thank you.
That's if you get a nice thing to factorise, yeah. If it fully factorises, fantastic. Some of them won't. In this case, everything here will. Because I haven't deliberately complicated it yet.
X to the power 3 plus b to the power of 2, x to the power of 2 minus 18, x minus 40.
Maybe I should have got these different things other than all F's, but...
Are you sure? Are you sure? Are you sure? 16 times 2. 32.
Cool, we all got a factor?
16 times 2.
Yes. Maybe.
32.
So everyone's got a factor. Is everyone already into trying to divide it? Or, oh, okay, right, you're already ahead. Good. Cool. Incidentally, what is the factor? -2 isn't the factor. X plus 2 is the factor, yeah? So
Oh, it's plus
Right.
2.
a solution to this thing equals 0 is x equals -2. The factor is x plus 2.
How is it x plus 2 not x minus 2?
So, go back to up here, right?
Oh,
Are you
yeah.
happy that a factor is x minus 3?
And you take it out the brackets, it's just positive.
Yeah. So you're okay with that?
Yeah.
Yeah.
I just did it wrong.
So good.
I did x minus 2 and x plus 2, and that's what gave me the answer as well.
Go.
Weird.
Who's on top?
That's not what's funny. So x squared times x is x cubed, x squared times 2 is 2x, and then the minus 3 is squared x. Hmm? What? Oh yeah, so that means that the x squared.
What is this one? This, I don't know what's going on. Crying.
Makes sense. X squared
We still going with the long div or?
yeah, don't worry, I'll be finished in like.
Okay. You guys are all good?
Yep.
Yeah. You guys are all good? Yeah, yeah, yeah. Gary's good? Yeah. Aaron, you're all fine? You're fine?
Yeah.
Cool. Let's get to that column. That's cool.
Alright,
TJ's good?
yeah.
Yeah. Fletcher Tyler?
Nearly there.
Nearly there? Cool. Out of curiosity, did you do the homework? Yeah? Good. Usually that's enough practice to get quick. Or did you make an error somewhere and then you're catching it? Yeah, okay, right. That'll happen. Fletcher's okay? No, he's looking a bit blank. Oh.
Boom.
Yeah. Yeah, so, and then you keep going. So this divided by, this gives me simple x, drops back here. So,
I just don't know how to work out that quadratic.
sorry.
I just don't know how to work out that quadratic.
Yeah, that's, okay, sorry.
Kind of, get myself in problem here.
Cool, right, so we just did a whole bunch of work. We ended up with double zeros at the end, so we know that everything worked out okay. Great.
We can think of this very different.
Therefore, what? Why did we do this? What did we figure out?
We figured out that the other factor.
The other factor.
The quadratic.
Yeah, this quadratic, yeah, okay.
So now you have the factors x plus 2 and their quadratic, but you can factorize it even further by simplifying factorizing their quadratic.
Beautiful. Okay, so therefore, what do we call this, f of x? Cool, therefore f of x, instead of being written as all this expanded, I could have got that, great. Cool, well we're happy with this x plus 2. Okay, I want to factorize this.
You know, what's that? Is it called completing the square?
I mean, you could complete the square, but it'll take a lot longer than
Recognition.
recognition.
X plus 5, x minus 4.
There you go. X plus 5, x minus 4.
Oh, okay.
Yeah, recognition's a winner. Whenever you can just look at it and go, oh, it's this. Saves you a lot of time.
And then
Cool.
x equals minus 2 plus minus 5.
There you go. Last bit. Therefore, x equals -2, -5, +4. Now, it doesn't necessarily matter which order you put your solutions in. It's usually put in increasing order, but it doesn't really matter.
Increasing magnitude or?
Usually order, but it
What
doesn't
is
actually
the
matter.
y value?
Yeah, just as long as you've got the solutions, it's fine. The only reason it's helpful is when we're about to draw things later. But even then, you draw them and go, oh, it has to go this way, it's fine. Cool. We're happy. Happy. Celestia, Gary, you happy with all that? Yep. You guys are happy? Yep.
Oh, how would it look like
Yep.
when you draw it?
Sorry.
What would it look like when you draw it?
Good question. That's what the rest of the board's for. Okay? So, that's solving them. Right? Solving them, if it's already factorized, sweet, saves you a whole lot of time. If you've got what are called repeated factors, great. There's even less solutions to worry about. If it's not factorized, you factorize it, and then solve as it was before. Right? A whole lot of methods is, well, not a whole lot, but a fair chunk of the starter methods is just like, here's an equation, factorize it. Here's an equation, factorize it. Solve it. How do I solve it? You factorize it. That's why we spent so long doing all that. Cool, alright. So I'm going to graph, ultimately I just want to graph this, but I'm going to use these as just guides for a scale. So, I'm going to go that way. I'm going to move these across a little bit. Oops, equals 2 squared.
Got any markers?
I did. Oh, a couple new ones anyway. I do like new markers. Make me happy. Okay. Cool, alright. Which of these is the easiest to sketch?
X.
Right, what does it look like?
Straight line.
Straight line going in which way?
Okay.
Say again?
Anyway.
Anyway.
Oh.
Y equals X.
Yeah.
What does that look like?
It just looks on
Straight.
the y-axis.
45-degree angle.
Okay, we haven't done linear in like 2 weeks and you've forgotten everything. Brilliant.
Yeah.
Okay.
It isn't a diagonal between two people.
It is diagonal. Diagonal going this way, diagonal going that way.
It goes this way
Yes.
because it's positive e.
Should be doing that. Shouldn't be horizontal or vertical or anything, guys. Right, y equals mx plus c. That's y equals 1x plus 0, so y-intercept 0, gradient of 1, so it's climbing up. Yeah. That's a little bit worrying, but okay.
We did it.
Yeah, eventually. Cool, alright, great. X squared, what does that look like?
A curve.
A curve, what kind of curve?
A parabola.
Parabola, what does it look like? Draw it in, just draw it in the air. Cool, nice smiley face. Wait,
Oh. So upside down.
that way. Not upside down. Smiley face. That. Try to make this
Should have been an art
to
teacher.
scale.
Oh. That's not unusual.
There. Cool, okay. So there's my quadratic. Brilliant, alright, do we know what x cubed looks like?
Is it on the side?
Is
Is it on a parabola on the side?
Okay, so is there an obvious pattern that this thing's going to follow? Not yet. We don't know.
It's gonna be like,
Sorry.
it's gonna be like, yeah.
Okay. Not quite.
Yeah.
So, okay. For the guys that have been in my class before, whenever I gave you a new graph, what did we do in order to figure out what it looked like? What did we do? Freak out. Okay, after you freak out. Alright, after you freak out, how do I always suggest that you attack a new kind of graph?
Put it.
Say again?
Make a table,
Make a table for
X and Y.
x and y, okay. So, put this x, y down here. Cool, alright, made a table for x and y, now what?
1, 2, 3, 4.
Negative 3, 3.
Okay, negative 3 to positive 3 is usually the numbers I suggest. In this case, we're just going to go negative 2 to okay, great. Okay, for this rule, what number would you like to start with?
-2.
0. Is -2 an easy number to calculate with
Right.
compared to the rest in the table?
0.
Right, 0 is the easiest. Start with the easiest number, just so that you warm into it. Okay, 0 cubed, 0, saves you a lot of time. What number would you like to go to next? Right, 1 cubed. What number would you like to go to next?
-1.
Okay, you could go either way at this point. I'm going to suggest we go to the right,
8.
since we've already started in that direction. 2 cubed,
8.
go back down. -1 cubed,
-1.
-1. -2 cubed,
-9.
go. Alright. Brilliant. Alright. Where was this thing crossing over? Yeah, there. Good. What were these two graphs? Well, where does x squared equal x? 1. Right? Right? So at 1 and at 0. Cool, so this must be at 1. Cool, 1, 1, 1. Sorry, -1. Cool, and therefore this is at 1. Okay, great. Well, let's plot this thing. Maybe I should plot this in green just to make it a bit stand out. Cool, alright, well, it's going to run through 0, 0, okay? It's going to run through 1, okay? And then after that, from 2, it's going to rocket off. Is it going to rocket off faster or slower than x squared? Faster, right? Okay, so this thing must be going off there. Okay, and we know that it goes through there. Alright? On the other side, similar story, it must be rocketing away after there.
Oh, I remember this.
You remember this now? Okay.
Oh.
Well,
Oh.
that's all well and good. In this case, using just 1, 2, 3, etc., that hasn't helped us that much. What number might help us a lot more to figure out the middle part?
0.
Okay, we've got 0, it runs through there, but I don't know where it's going in this section.
Oh, is it 1?
Right, half would be useful, right? Because I know where it is at 0, I know where it is at 1, but I need to know where it is in between. Okay, so let's try a half. A half to the power of 3. 1 on 8. Okay. So there's half, there's quarter, there's 8. So it looks like it goes about there. Similar story. Half, quarter, 8. Somewhere in there. Oops. -half. Looks like it goes about there. Cool. How do you presume the graph might go from here? Draw it in the air.
Sound effects.
Most of you got a pretty good idea.
Sound effects are necessary.
Sound effects aren't necessary. There you go. Cool.
What is this called?
Not hyperbola?
Is it for rubber Latin?
Oh, yeah.
Okay. What kind of equation is this?
A polynomial.
Okay, it is polynomial, specifically degree 3, which is called cubic. So this graph is cubic.
Cubic.
Brilliant. Cool. So that's what a basic cubic will look like. Right, x cubed. Great. So things that I want you to notice, other than, well, okay, things I want you to notice, runs through 0 still for x cubed, runs through 1, 1 still, right? Runs through -1, -1, fine. It's actually under the lower powers to begin with, and then becomes greater than them only after 1. And similar story on this side, it's actually tucked under the other ones, and then only after -1 does it actually rocket off. Yep.
The x's, that doesn't intersect the x's.
They're intercepted at 0. This is this one, yeah?
Yeah.
Right? So if you solve that x cubed equals 0, right, you've got this. That's the same as x minus 0 all cubed, yeah?
Yeah.
So therefore x equals 0 3 times. So it's just x equals 0 is the only x-intercept.
Oh, even for any other or one of these. So for
Just for x cubed. We're going to do some more here. So that's good. You're asking good questions. You're asking good questions. You're anticipating what's about to happen. So that's good. Okay, well, let's think about this guy.
And it's gonna go like this. It's gonna go like this, is it?
Maybe,
So this
depends
side's
what
gonna go
this
up and this
means.
side's gonna go down. So the parabolas would go down
Not
and
quite.
up and left
You're
right.
playing with good ideas, but you're not quite nailing that. Okay, cool, alright, we've got this. Do we know what these things look like? Okay, it seems to look something like that, great. Do we know what the 2 and the 1 are going to do to it?
The one is gonna make it so it intercepts the y at 1. And,
No, the plus one's just gonna move it right.
Okay, so we've got a couple of hypotheses that are going to yield different results.
I mean, no,
So,
plus one's gonna just make it
let's
move
figure
up.
this out.
And then the negative is gonna make it move right.
I'm not expecting you to necessarily guess it straight out. You've got enough pieces to put it together, but I'm not expecting you to like immediately go, oh, I'll put this entire puzzle together up here. Right? I'm just laying down pieces and then seeing what spits out. Okay. What might be a good idea at this point?
Plus one.
table.
Table, right? Because we don't know what it looks like, we need to know what it looks like. Okay, so X, Y, 1, 2, 3, 4, 5, 6. That one.
-1, -2, -4.
Cool. Okay, great. What number would you like to start with?
0.
0. Yeah, almost always start with 0. Cool, alright, 0 minus 2,
2.
negative 2.
-2.
Yeah. Cubed,
8. -8.
negative 8, plus 1,
-7.
negative 7. Be careful with your negatives there. Okay, 1,
Negative.
1 goes to 0.
No, sorry.
So 1
-1.
with negative 2 goes to
-1.
negative 1 cubed, still
-1.
negative 1, plus 1, 0. Cool, alright. 2, right, 0 cubed, still 0 plus 1. Cool, cool. 3, alright, end result becomes 2. Yeah, cool. And then we're just filling in the table, and this is going to go negative 26, I think.
What?
Negative 4, 64, negative 63, negative 520, 124. Right. So, are we interested in this side?
No.
No, why not? Right, this is racing away. Yeah, so we don't really care. That must be this part of the graph, which isn't interesting, it's just racing off. Cool. What parts are we interested in?
The positive one.
Okay, the positive side seems more interesting. We'll keep the 0 and the negative 1, just so we've got that part of our axis. Which way have we got? This way, this way? Yeah. 2. Seven's down there somewhere. Should have made those smaller. Negative 1. Okay, we run through 0 is negative 7, which is way down there somewhere. 1 goes to 0. That goes to there. 2 goes to 1. 3 goes to 2. 3 goes to 2. Okay. Alright, this thing's way down here somewhere. Okay. Based on that, how do you think this graph goes?
Like that.
Like that? What was that? Draw it again. Okay.
It's going in the same direction.
Well, these 3 are all 1 apart. These 3 were all 1 apart. Alright, so this is going to end up like that.
Is that what it's going to look like?
Now, if I was to ask you, where is the middle of this graph, where would you say?
Oh, I'd say in between 2 and Yeah.
Say again.
1.5.
2.5.
2.5?
1.5 and
Like
1.5.
x 2 on, oh wait, no, sorry, x,
Between 0 and 1.
Between 0 and 1? Okay, let me rephrase my question
It's
then.
between 1 and 2, isn't it?
Where has this graph become kind of symmetric?
2-1.
2, 1, right? At this point, 2, 1,
oh.
But isn't it
I was
between?
doing
Right.
1 between that.
it curves up and curves down,
Ah.
right? Now, is that symmetric?
No.
No, right, because it doesn't flip straight across. But it's got some weird behavior here where it's like kind of a double kind of symmetric, because if I flip it over and then flip it again, then it's like that double symmetric sort of thing.
Symmetrical.
Yep.
It's got radial symmetry.
Radial symmetry,
Doesn't mean you can spin it.
rotational symmetry.
No.
Yes. Rotational symmetry about this, if you make that the origin, yes. We're going to massively simplify on that. This thing is going to be called a point of
Interception.
inflection.
Is that even
Yeah, it's a stationary point of inflection, but we don't care about that
I had
part.
inflection on my finger one time.
Okay. So a point of inflection is where it's going slower, 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 and now it's going faster, faster, faster. It also changes its mind about what it wants to do. G'day. Good? Okay.
Oh, thank you.
Cool. Well, that's interesting. Because of all of the places where this point of inflection could have ended up, it ended up at 2.
And 1.
1.
Oh my gosh. It's that H and K stuff.
Right, H and K stuff. Right. X minus H, Q, plus K. Right. Then what? There you go. Cool. So whenever you have a form like that, you're always going to end up with something. Cool. Goes slower and slower, slower as it approaches HK, and then takes off again.